Hey everybody. The unit we just finished up focused mostly on adding, subtracting, multiplying, and dividing rational numbers. The unit we're beginning tonight is going to move away from arithmetic and more into studying algebraic concepts. And we're going to start with writing expressions and equations. One of the reasons we learn algebra is because we can use it to represent, analyze, and solve situations in the real world. And what we're going to learn tonight is going to be the first step of that. This table here gives us some key words that we can look for in different situations that'll help us translate from words to math. So here we have the different operations: addition, subtraction, multiplication, and division. And we have some key words that'll clue us into which operation we want to use. For instance, if we see sum, that means we're going to want to use addition. So if we see the sum of 2 and a number x, we're going to write that as 2 plus x, right? A number n plus 7, that tells us right there that we're going to use addition, n plus 7. With subtraction, we're going to look for words like difference, less than, minus, decreased by, right? The difference of a number n and x is n minus 6. A number y minus 5 becomes y minus 5. Now, with addition and subtraction, there's two situations that we really want to look out for. If we see more than or less than, and you'll see what I'm talking about when we get down to our examples here. Multiplication, big one to look out for is product, right? The product of two numbers, 12 and y, is 12y. When we're looking for a fraction of a number, we also use multiplications. For instance, if I want to find 1/3 of a number x, it's 1/3 times x. If I wanted to find 2/5 of a number a, it would be 2/5 times a. With division, a big one is quotient. We'll see quotient a lot. If we have the quotient of a number x and 2, that will mean x divided by 2. The quotient is the answer to a division problem. So here we have three examples, and let's practice translating from this verbal phrase into an algebraic expression. Example A here says 4 less than the quantity 6 times a number. Now this is an example that we talked about earlier. When it says 4 less than the quantity 6 times a number, that means we're going to start with this. 6 times a number. And it's 4 less than that, so we're going to take 4 away from that. So whenever you see those words less than or more than, we always want to put the number at the end. This goes at the end of the problem. 6n minus 4. Example B, we have 3 times the sum of 7 and a number y. Now this one's kind of tricky because we have two things going on here. We have 3 times and we have the sum. Now I'm multiplying 3 by the sum of 7 and y. So I'm going to write the sum of 7 and y first. And we're multiplying 3 times this sum, so I'm going to put parentheses around it. 3 plus 7y is the expression. Example C, we have the difference of 22 and the square of a number n. So we have the difference here of 22 and the square of m. So we're going to write that as 22, difference means subtraction, minus, and it's the square of m, so I'm going to put m squared. We can also translate a verbal phrase into an equation. The only difference between an equation and an expression is that an equation has an equal sign. An equation compares two different expressions by saying that they're equal. In example D here, we have 6 more than the quotient of a number c and 5 is 19. Now this is another one of those cases where we have this than here. We have 6 more than. So we need to start with the quotient of a number c and 5. Remember, quotient means division. So c over 5, and it's 6 more than that. So I need to add 6, and that equals 19. It is 19. This whole phrase before this is 19, so it equals 19. In example E, we have the product of 4 and the difference of a number b and 2. So we're multiplying here because we have the product, and we're multiplying 4 and the difference of a number b and 2. So the difference is b minus 2, and we're multiplying that difference by 4. We can just write that 4 in front of the parentheses, and that is 12. That means it equals 12. So 4 times b minus 2 is 12. In example F, here we have this less than again. 5 less than twice a number x is 23. Now if I want to have twice a number, think about it. Twice 5 is 10. I'm multiplying by 2. So 2x, and it's 5 less than that. I'm taking away 5 is 23. What we really want to be able to do with algebraic expressions and equations is use them to represent real-world situations. In our first example, it says, you work at an ice cream shop with 5 friends. At the end of each shift, you split the money in the tip jar, $T, evenly. How much money does each person get? We know we have $T, and we know we're going to split it 6 ways. It says 5, but keep in mind, you also work there. So we actually have 6 people that we're splitting this money. Now splitting is dividing, so we're going to do T divided by 6, and that's how much money each person's going to get. If T is 30, if there are $30 in the tip jar, 30 divided by 6 is 5. Everybody's going to get 5. If T is 12, everybody's going to get 2. But T over 6 represents the amount that each person gets. Our next example says that each math problem takes you m minutes. How long will it take you to do 12 problems? Well, if each problem takes me m minutes, and I want to know what the total amount of time is going to be, I'm going to need to multiply this. I'm going to need to find the product. So 12 problems times m minutes each is going to give me my total, right? If it takes me 3 minutes to do each problem, 12 times 3, it's going to be 36. If it takes me 1 minute to do each problem, it's going to take me 12 minutes total. So that's how we can use algebraic expressions to represent the answers to real-life problems, even if we don't know one of the numbers.